Alright, November 2025. So this is the combined science paper, the paper 2, the theory paper, which was written this year from the ZIMSEC exam board. So we are going to revise this paper section by section in preparation for my end of years and those who are for the June examination, right? So we are starting with section A. We are starting with section A, where you are required to answer all the questions. So you should always remember to read and to take note of these instructions to candidates, right? So always remember to subscribe to our YouTube channel, and always remember to follow us so that you'll be notified whenever we post, right? So the first part of the question says, name two types of teeth and give one function of each. So we are required to name and to give the function. So we have 4 types. We have incisors, we have canine, we have premolars, and then lastly we have molars, right? So first you should know the general appreciation of the anatomy of the mouth, right? So we're going to have 4 incisors, and then we are going to have 2 canines, and then we are going to have 4 premolars, and then lastly we are going to have 6. So 4 on the top, and then 4 on the top, and then 4 on the inferior surface, and then 2 on the inferior superior surface, and then 2 on the inferior, and then etc., and then the same thing, right? So we're going to have a total of 32 teeth in the mouth. So you should know this general appreciation of the mouth, right? And then we are required to give the function. So the function of the incisor is to cut in the cutting of food, right? And then the function of the canine is for tearing soft food. And then for premolar is to grinding and crushing. And then lastly we have the molars. The function of the molar is the thorough grinding and crushing food, right? So these are the general functions of the teeth, right? So the first thing you should know the amount, or you should know the number of teeth in the mouth. We have 32. We have 4 incisors on the top, and then 4 on the inferior surface, 2 on the top, 2 on the inferior surface, 4 on the superior surface, 4 on the inferior surface, and then the same thing, right? So you should just appreciate, right? So we are now moving on to the next part. So the next part says, explain the importance of chemical digestion, and this is awarded for 2 marks. Explain the importance of chemical digestion. So you need to understand what is meant by the term digestion. So digestion is defined as a biological process whereby complex and then insoluble and then large food molecules are being converted into simple and then soluble and then smaller food molecules. So this is the general definition for digestion. Your definition must include these terms, right? Complex being converted into simple, insoluble converted into soluble, and then large converted into small, right? So we are required to define or to give the importance of chemical digestion. So here they've specified that we want chemical digestion, not just digestion. So we have 2 types of digestion. We are going to have mechanical digestion, and then we are going to have chemical digestion, right? So mechanical is done in the mouth mainly by the chewing, by the teeth, right? This is mechanical digestion, the chewing of food. And then for chemical, we are going to have enzymes. We are going to have the use of enzymes, the use of digestive juices, right? We are going to have the use of enzymes and the use of digestive juices, right? Know the chemical digestion. So first you need to understand that what is meant by the term chemical. What is this chemical referring to? So chemical is referring to the use of enzymes and the use of digestive juices. So you need to know the definition of the term enzyme and to try to give the example in preparation for other exams. So here don't mainly focus on the given question, but you try to expand the question by dissecting out the fundamental principles within that given radius, right? So you need to understand the definition of the term enzyme. You should be able to define the term enzyme and to give my examples, right? All right. So here, the importance of chemical digestion is to break larger, complex and insoluble food molecules into simple, smaller and soluble food molecules by the use of enzyme or digestive juices, so that they can be absorbed in the bloodstream and they can be used for energy, growth and repair. That's a simulation, right? So we are saying that these are going to be broken so that they can be absorbed into the bloodstream and used by the body for energy and growth and repair, right? As simple as that. And then we now move on to the next part of the question. So the next part says, name the enzyme that converts starch into maltose in the mouth. So starch is a polysaccharide, right? It is a polysaccharide. So we have monosaccharide, we have disaccharides, we have polysaccharides. So these are the polymers, right? And then this one, maltose, it is a disaccharide. So a disaccharide is formed by two monosaccharide forming what we call a glycosidic bond, right? A glycosidic bond. So we have amide linkage, we have ester linkage. So amide linkage is found in the proteins, and then ester linkage in the fats, and then the glycosidic linkage in the carbohydrates. So we have what we call a glycosidic bond. So we are going to have two monosaccharides bonding together to form the disaccharide, and then the disaccharides, they will combine together to give the polysaccharide. So this is the chain. So this is the monomer, this is the repeating unit, and then this one is the polymer from the chemistry point of view, right? So maltose, we have maltose formed by two glucose molecules, and then we are going to have sucrose formed by glucose and fructose, right? And then we are going to have lactose formed by glucose and galactose, right? So these are the simplest units making up these repeating units or disaccharides. And then the disaccharides will combine to give the polysaccharides. So you need to know, you need to understand and to appreciate how these biological molecules interact, right? So the question says, name the enzyme that converts starch into maltose. So you're writing down starch, the polymer, into these simpler units. So we are going to use the enzyme. So the question says in the mouth. We are given the location, right? So in the mouth, you are going to have salivary amylase, right? But if the question says name any enzyme which converts starch to maltose, we are going to have a lot of enzymes. We are going to have the pancreatic amylase. But the question specifies that we are going to use the mouth as the venue of the reaction, right? So we're going to have salivary amylase. Are we together, guys? So you need to know that for the breaking down of the larger biological molecules, which enzyme are we going to use? If you're breaking down the proteins into amino acids, which enzyme are we going to use? So you have the same trend. We have the polypeptides, and then we have the dipeptides, and then we have the monopeptides. So the monopeptides, these are the amino acids, the simplest units, right? And then the dipeptides and etc., right? So you should know this general trend, right? And then we now move on to the next part of the question. So the next part says Fig 2.1 shows an organ in the human respiratory system. The organ in the human respiratory system. So you should know, you should appreciate the general anatomy of these four systems. The general anatomy, the general structure of these four systems. So you should appreciate the respiratory system. You should appreciate the GIT, or the alimentary canal, or the gut system, right? You should also appreciate the CVS, the cardiovascular system, right? And then you should also appreciate the genitourinary system, right? You should appreciate the simplest structures, right? You should know the anatomy of the simplest structures. All right. So we now dive into the question. So the question says, identify the organ, right? So which organ is this one? So these are what we call the air sacs. These are the air sac or the alveoli, right? So we can say the alveoli or the air sac. As simple as that. As simple as that. This is the general appreciation of these structures, right? And then the next part of the question says, state the function of the organ. State the function of the organ, which is the alveolar. So the function is for gaseous exchange. Gaseous exchange. As simple as that. So you should appreciate the structure. You should know how to label these structures and to give the general function, and also try to understand how these structures are adapted to their function. How is the alveolar adapted to their function? How are the bronchi adapted to their function? How is the trachea adapted to its function? Right? You should understand the general adaptations of these structures or these organs to their function, right? All right. And then we now move on to the next part. Describe and explain one adaptation of the organ to its function. Describe and explain how this organ is adapted to its function. As simple as that. So you need to know how, as we have alluded to before, you should know how the alveoli is adapted to its function. So here we are having this alveoli, right? So you need to appreciate how this alveoli is adapted to its function, and all the other organs in the respiratory system, the CVS, the GIT, the genitourinary system. You should know how these are adapted to their function. All right. So first, for the alveoli have a larger surface area, meaning to say you've increased surface area for efficient gaseous exchange, right? So we can say large surface area, right? And then their large surface area to increase efficiency of gaseous exchange, right? And then we go on their thin walls for easy diffusion of gases, 1 cell thick, right? So we can say, in other words, one cell thick. Why? For easy or allowing fast diffusion of gases, right? And then we can say they have a moist lining, right, which aids to the faster diffusion of gases, right? For easy diffusion. Are we together? And then they are highly vascularized. Meaning to say they have a lot of blood vessels. So rich blood supply. They have a rich blood supply to create a steeper concentration gradient to aid for faster diffusion. As simple as that. So these are the adaptations of the alveoli to its function. So you should know the adaptation of the alveoli. You should know the adaptation of all the specialized cells. You should know how are they adapted to their function. The red blood cells, the root hair cells in the plants, the xylem, the phloem, and etc. You should understand how these structures are adapted to their function. As simple as that. So the trend is well defined. We know this year, if they are not setting this, they are going to set this one. If they are not setting this, they are going to set this one. The trend is well defined. So you should just follow our playlist, just interact with all our discussions, right? So that you have the idea of what's going to be in your exam, right? So we are now moving on to the next part. Describe and explain the effect of tobacco smoke on the organ labeled 2-1, right? So in tobacco we have tar, we have nicotine. So this destroys the alveolar wall, reducing the surface area, leading to emphysema, right? So they destroys the alveolar wall, reducing the surface area for gases exchange, the surface area leading to emphysema, right? And then we also have reduced elasticity, and we have a reduced vascularization due to embolism and thrombosis, and then we have inflammation and the mucus built up within the alveoli and the other airways, right? And then we have impairment of the cilia. So this one, you need to take note of this one. Let me use another color. Impaired cilia function. So first you need to understand the function of cilia, and then try to understand how smoke affects the function of cilia. So we have what we call paralyzed cilia, right? Are we together? And then we also have what we call carbon monoxide exposure. So we're going to have an increased carbon monoxide exposure. So carbon monoxide bonds with hemoglobin to form what we call carboxyhemoglobin. So carboxyhemoglobin is very stable, right? So we are going to have a reduced amount of hemoglobin within the circulation, thereby decrementing the oxygen carbon dioxide circulation within the blood, right? So this is the effect of carbon monoxide exposure, right? And then we are done with number 2, and we are now moving on to number 3. So number 3 says the nucleide notation of an element X is shown. This is the nucleide notation. So first we should be able to define the term element, the term compound, the term atom, what else? The Avogadro's number, the Avogadro's constant, and the Avogadro's law. The concentration, solubility, solvent. You should be able to define this simple definition. Why 1 mark? They're going to come with 1 mark. So you should be able to define this simple definition. Are we together, guys? All right. So the statement, the first one says, state the number of element, the mass number of element X. All right. So this is the nucleide notation, and then this is A, this is B, and then this one is A. So we said in our discussions, A is the proton number or the atomic number, and then B is equal to the mass number, which is the sum total of protons and neutrons. So for a neutral atom, the number of protons is equal to the number of electrons. For a neutral atom, what is a neutral atom? A neutral atom is one which doesn't have any charge. So we have charged particles which are called ions. So we have 2 types of ions. We have what we call the cations and the anions, right? So this one is a neutral atom. It doesn't have any positive sign here or any negative sign, meaning to say the number of protons is equal to the number of electrons. So this is what you need to know in terms of the nucleide notation. This is what you need to know. And once you know this, you are good to go for any equation requiring this nucleide notation. All right, state the mass number. We said B is the mass number, meaning to say 40, right? So we are simply going to say 40 here. Are we together? And then we now move on to the next part. So the next part says state the number of protons in an atom of element of X. So we said A is the proton number or atomic number. So A is equal to 18, right? So A is equal to 18. Are we together, guys? And then we now move on to the next part. So it times the number of electrons. So the number of electrons is equal to the number of protons for a neutral atom, right? And then we go on to the next part. Draw a cross diagram to show the electronic configuration of element X. So we need first to understand the definition of electronic configuration. So electronic configuration is defined as the regular arrangement of electrons in their electric shells, right? It is the regular arrangement of electrons in their electric shells. So we are required to give it as a cross diagram. So we have got 2 methods of writing the electronic configuration. We have this one. So we have 18 electrons in the outermost shell. The total number of electrons is equal to 18, right? So we are going to use this one. So the first shell is filled with 2 electrons, and then the next one 2 electrons, and then we are left with 8 electrons. So this one is what we call the noble gas. So noble gases, you have got 8 electrons in the outermost shell, right? We have 8 electrons in the outermost shell or the valence shell, right? So the first shell is filled with 2 electrons, the duplet state, like that one of helium, and then the other shells are filled with 8 electrons. So you should know this general appreciation for the electronic configuration. So here we are required to give it as a cross diagram. So we are simply going to write it in this form to show the shells, right? Don't mind my drawing. Alright, so the first shell is filled with 2 electrons. Here are the 2 electrons. The next one with 2 electrons, 2 electrons, 2 electrons, 2 electrons. And then the next one with 2 electrons, 2 electrons here, 2 electrons here, 2 here, 2 here. So we have another question which says, why are we pairing these electrons? Why are we pairing these electrons? Why are we not saying 1, 2, 3, 4, 2? We reach the number 8. Why are we pairing these in groups of 2s? And why are we spacing the electrons? So you should understand what we call the subatomic table. We have what we call the subatomic table, which explains the subatomic particles. So we have explained this table. We have explained the charge. We have explained the deflection in the electric field, in the magnetic field. We have explained these things, right? So you should go on our playlist and understand why we separate these electrons, right? Alright, so the question says, state the group number of the periodic table to which the element X belongs. So for you to have a clear picture of the group number without guessing, what you need to do is first to write the electronic configuration in this format. This number at the end, the number at the end, the valence number, what you call the valence number, the number of electrons in the outermost shell denotes the group number. So if you are having 8 here, the group number is equal to 8. If you are to have 4 here, the group number 4. If you are to have 7, the group number 7, 1, group number 1. This is the easiest way to have the group number using the electronic configuration, right? So the group number is denoted by the valence number, and the number of shells is denoted by what we call the period. So this element is in period 3, group 8. As simple as that. Period 3, group 8. So the question requires us to give the group, so you can say group 8. At times group 8 is also called group 0, but this is chemistry, but we are doing combined science, right? So we want to stick to the simple terms for combined science, right? So state with the reason any one chemical property of the element X. State with the reason any one chemical property of the element X. One chemical property. So the question requires us to give the chemical property, not physical properties. So physical properties, these are temperature, conduction of electricity, and etc. But here we are being required to give the chemical property. So you should be able to understand which property am I giving. Am I giving the correct, the required property, or I'm starting to create my own question, right? So you're being required to give the chemical property. So what governs the chemical property? The rearrangement of electrons is what determines the chemical property. So we are having 8 electrons in the outermost shell, meaning this one has a stable or a full electronic configuration, what we call the octet rule, right? So they have a full electronic configuration. So the reason why elements react is to attain this electronic configuration, that one of a noble gas, right? So this one is this one have the full electronic configuration, meaning to say it doesn't have any reason to react. It has a full electronic configuration, so it doesn't react. It is chemically innate. Why? Because it has a full electronic configuration. So we have 3 reasons. We have 3 ways the elements react. They react either by sharing, either by gaining, or by losing electrons. So this one, or these reasons, is to attain stability, like that one of a noble gas, to have 8 electrons in the outermost shell. So this one doesn't have the reason to react. Why? Because it has a full electronic configuration. It has attained what you call the stable noble gas electronic configuration, the octet rule, right? So we are not going to have any reaction for the noble gases, and you are being awarded for 2 marks. And then the next part says state 2 products of complete combustion. State 2 products of complete combustion. So we are going to have carbon dioxide and water. So these are the complete combustion products of hydrocarbons. Hydrocarbon defined as an organic compound which contains only hydrogen and carbon, right? And then we go on to the next part. Describe 2 ways by which a community can be educated about the dangers of incomplete combustion. 2 ways by which a community can be educated about the dangers of incomplete combustion. How can we educate the community on the effects of incomplete combustion? So first you need to carry out public awareness campaigns through the use of posters, through the use of social media and workshops to educate the community on the effects of carbon monoxide, which is one of the products of incomplete combustion, right? And also you can educate the community on the proper ventilation when using fuels. And we are going to have public awareness campaigns. We are going to have lessons on proper ventilation when using fuels. So the next part says explain how deforestation can lead to global warming. So first you need to understand the term global warming, the gradual increase in temperature, and then to understand what is deforestation, the uncontrolled cutting down of trees. So by cutting down of trees, we are reducing the surface area for photosynthesis, since the leaves absorbs carbon dioxide during photosynthesis. So we're going to have an increment in the amount of carbon dioxide in the air, since we have reduced the surface area for photosynthesis, right? So increment in the carbon dioxide in the air, which is a greenhouse gas, will enhance the greenhouse effect, the greenhouse effect, thereby leading to what we call a global warming. So first you need to understand that deforestation reduces the surface area for photosynthesis, thereby increasing the concentration or the amount of carbon dioxide in the air, which is a greenhouse gas, thereby increment in the greenhouse effect, which leads to global warming. And also you need to define the term global warming, as simple as that. And then we go on to number 5. And number 5 says a block is 10 centimeters long, and then 5 centimeters width, and then 2 centimeters thick, and it has a mass of 200 grams. So this one is what we call physics section, right? So this is the physics section. So we need to define mass, the amount of matter in a substance, weight, the influence of force of gravity on mass. So you should be able to define these terms, right? And then the next part says calculate the density. So you should be able to define the term density, right? And then density is denoted by rho, right? Density is equal to, so density is not denoted by D, it is denoted by rho. So density is equal to mass over volume. So we are having the mass is 200 grams, and then this one is the dimension. So volume is equal to length by width by height. So 10 by 5 by 2, right? So 10 by 5, 50 by 2, 100. So we're going to have 100 cubic centimeters is our volume. And then we go on to the mass. You have 200 grams over the volume, 100 cubic centimeters. So we're going to divide this by this 2, and then grams over cubic centimeters. As simple as that. And it is awarded for 3 marks. And then we go on to the next part. So the next part says Fig 5.1 shows a loaded National Railways of Zimbabwe, the wagons being pulled by a force of 900 newtons. So you should be able to define the term force. You should be able to know the Newton's laws of motion, like the 3 laws of motion from Sir Isaac Newton. Alright, and then name the force represented by 150 newtons. So this force. So this one is what you call the frictional force, the force which opposes motion, right? So the motion is going in this direction, and this one is going in this direction. So the force which opposes the flow of motion is what we call the frictional force. And then the next part says state one way by which the wagons have designed to reduce the named force in B1. So we have named this one as frictional force. So how are these designed in a way of reducing friction? So they have what you call the lubricated bearings. So they have lubricated bearings to reduce friction, right? And then we go on to the next part. we go on to the next part, which says state the importance of the force named in B1 to a moving vehicle. What is the importance of friction to a moving vehicle? So the importance of friction is for braking, right, to prevent skidding, and also allowing for acceleration, right? So friction provides traction to the moving vehicles. It also allowing for acceleration, braking, and also preventing skidding. Are we together? As simple as that. And then we go on to the next part. So figure 6.1 shows the states of matter. So we are having liquid, gas, and then solid. So you should understand the kinetic theory of matter, basing with these three states of matter. So name the change of states of matter represented by the letter A, B, and C. A, B, and then C. So for A, you are moving from solid to liquid. So this is what we call melting, right? From solid to liquid. And then from B, we are moving from liquid to gas. Liquid to gas. So this is what we call evaporation, right? And then lastly C, which says from gas to solid. So which is C. This one is our C, right? So from gas to solid, we are going from solid to gas. All right, let us start with solid to gas. We're going to have sublimation, right? So from gas to solid, we're going to have reverse sublimation, or D sublimation, right? And we are done. So this one is what we call D sublimation. And then the next part says state one example of a substance which undergoes process C. So this one is our process C. So example of D sublimation, we're going to have the formation. We're going to have formation of soot, which is a solid carbon forming from a gas formed by incomplete combustion, right? Incomplete combustion. As simple as that. And then we now move on to the next part, which says state one condition which is required for process C to take place. So we're going to have decrement in the temperature, or reduce temperature, or the cooling effect, right? And then we now move on to the next part. So the next part says explain, part number B, explain how an increase in temperature increases the rate of dissolving a solid. So first you need to understand what you call the kinetic theory of matter. So increase in temperature results in increase in the kinetic energy of the particle, thereby resulting in the increment in the frequency of effective collision, right? So thereby breaking down the lattice structure, resulting in the dissolving of the particle, or the solid matter, or the solid element, or matter, whatever the solid is, at a faster rate. So we are going to have increase in temperature. It will result in the increase in kinetic energy of the particle, thereby increase in the number of effective collisions. Thus the particles are colliding frequently, right? Thereby increment in the rate of breaking of the solid lattice structure, thus increasing the solubility. As simple as that, right? And then we move on to the next part. So we are now on section B.